Good afternoon. Welcome. Billions of dollars are lost to fraud every year by organizations. According to Javelin Research, new account fraud was $3.4 billion in 2018, up from $3 billion the previous year. Account takeovers have increased 50 to 150% year over year. Fraud is top of mind to many, and it's top of mind to your customers who are ultimately impacted by this. Hi, my name is Ryan Schmiedel. I am the GM of Fraud Prevention at AWS, as well as the new service Amazon Fraud Detector. Next to me is Kara Saro, our guest from Charles Schwab. And next to her is Nick Tostenrud, Senior Manager for Product of Amazon Fraud Detector. Today, we're going to give you a deep dive into the new service and talk to you about some of the MOs, the fraud vectors, as well as the machine learning techniques and some of our learnings over the course of the year that have gone into this service. But before we get into the details, let me let Kara take an opportunity to explain herself, her role, and your organization.
Thanks. Hi, I'm Kara Saro. Thanks for joining us this afternoon. I wanted to give you a little bit of an overview of Charles Schwab for those of you who aren't familiar with the company. Schwab is a financial services organization that has over $3.5 trillion in client assets. That's today. I don't know if any of you have been following the news, but it would appear that in the near future we will be acquiring a few more dollars, give or take a couple trillion. We have three primary businesses: brokerage services, banking services, and retirement plan services. Within Schwab, we have a financial crimes risk management group. That group has about 350 people who are dedicated to protecting our clients and the firm from financial crimes, including money laundering, conduct risk, and fraud. My team is the fraud surveillance and investigations team. I have about 100 people across 6 individual units. They're responsible for fraud prevention, detection, mitigation, and remediation. And through those efforts that we've come to know Ryan and Nick and become familiar with Amazon Fraud Detector.
Thank you, Kara. We're going to get an opportunity, Kara and I, to talk a little bit about some of our learnings in fighting crime and fraud over the course of the last few years. But overall, in the next 50 or so minutes, we're looking to accomplish a couple things for those of you in the audience. One, as I said, we're going to review some of the learnings from fighting crime, both online as well as in the financial institution, share some of the things that we have done and some of our strategies in which to attack this problem. I'm going to then give a primer of machine learning for fraud prevention purposes. We'll talk a little bit about what we do, how we do it, some of the things that give us extra juice, so to speak, and some of the things, as you're going to learn shortly, that go into this new service, Amazon Fraud Detector. And then the latter part of it, we're going to dive into the details, demonstrate the product, and talk a little bit about some of the key features and takeaways of the service. But before we kind of do that, why don't we do a quick preview of Fraud Detector in action? So Nick, I don't know if you want to take it over and show us how it might work.
Sure. Okay, what you can see on the screen here is that we have a demo web app for a made-up company called AwareBank, and we have a sign-up flow here that we've integrated with Amazon Fraud Detector's API. We dynamically adjust the flow based on the risk that the service is returning. So I'll go through an example registration with a low-risk sign-up and then with a high-risk sign-up. So as you can see here, the sign-up was accepted. The customer receives a thank you for registering. Down in the bottom left, you'll see that the model that's used with Amazon Fraud Detector returned a risk score of 431, which is below the 500 threshold that we have configured. And then the outcome that was returned was low risk pass. Well, let's try this again with a higher risk sign-up. Now, as you can see, the customers asked for some additional verification information on the fly. So what we wanted to demonstrate here is that Amazon Fraud Detector can enable you to dynamically adjust the customer experience based on risk. Later on in the presentation, we'll show you the console experience that can help enable this type of CX.
Thank you, Nick. And again, you probably noticed that there was only a few attributes passed, and that's part of the key to the service. One of the things that we have learned over the course of time is to gather limited amounts of data, use that data effectively to assess risk, and use that to manage, so to speak, the customer experience. For trusted customers, we have an optimal experience. For those that maybe not as trusted, we may ask for some different information, just like you saw right here. So, at any rate, we'll get into the service a little bit more. But before I do, it's one point, just to hint for questions. Please hold them to the end. We'll try to do our best to leave a few minutes to answer some questions, as well as I'll share all of our contact information for those of you that want to follow up with some more details. So, with that, let's jump in and let's start discussing and sharing with you some of the things that we've observed, some of the problems that both Charles Schwab and AWS and Amazon have covered. So, how many of you guys are sitting there thinking, what kind of fraud does AWS deal with? Right? Does that cross your mind? It did when I took this job. So as you'll notice, there's a lot of the same types of fraud patterns that we see at AWS that you see in banks, that you see in e-commerce, that you see in hospitality, especially online. You've got 3 buckets. Payments, people trying to use payment instruments, whether they're stolen, compromised, whatnot, in order to steal services. It's a regular thing that we deal with across the board every day. Account takeover. Everyone basically has had that situation, or in this role has seen these situations where bad actors are attempting to take control of a legitimate account and use it for their own purposes, as well as abuse forms. Let me dive into payments, just to give you a little bit of some background. We are a post-pay service, right? What that means is that when you sign up, you get an account, you give us a form of payment, and you start using our service. You pay for what you use, and that typically happens at the end of the month, right? That creates a couple challenges. One is you can't do an auth, I can't do a hold. They last 48 hours, maybe a little bit longer, depending upon the institution. It's already gone. So for us, understanding the risk when you actually sign on and create that account and treating it accordingly is really important for us to manage losses in this world, right? 2, when we start going from a prepaid perspective, in certain areas of the world, we accept, actually we do it all over the place, prepaid cards, right? Again, a prepaid card, you don't know how much they're going to use. You can do an auth, it can go through, and if they start basically using and consuming services beyond what's on that card, there again, you're left holding the bag. So there are 2 elements of that, and again, there's a lot of different things we have to deal with, but prepayment fraud or payment fraud is a big element, and we have to look and have built models and time and expertise trying to assess the risk at new customers and treating them accordingly. Account takeover. Account takeover comes in a couple forms for us. One, just like everyone else, you'll have folks that acquire username and passwords via the dark web or whatnot, and folks are trying to compromise that account by signing onto the console. And so we have mechanisms in place in order to detect that anomalous behavior. We also have another type of thing, which is called this API key. How many of you guys have used an access key before? Probably everyone has in the audience. How many of you have actually put your access key in your code and stored it in GitHub? Okay, no one's going to admit it, are they? So if you do, you will get probably a nice email from my team explaining to you that your account has been quarantined and that you need to come talk to us and clean your account up. Every day there are actors that are looking on various places for these keys, use these keys for their own purposes to take over your account. So if you take away nothing today, just take that away from you. Abuse. So we have all kinds of different types of abuse, and abuse is really defined from the position of your organization. What types of activities do you want to prevent? For us, there's lots of different types that we look at. Common things are free tier abuse, promotional abuse, folks that are trying to use some sort of promotion and create hundreds of accounts trying to figure out how they either sell the accounts or chain the accounts together in order to do something for free. Premium phone number. Folks that basically have these phone numbers that they get paid for, so they'll find ways in which we'll have to call back that phone, that for-fee phone number, and of course that's how they pocket money by doing this at scale and at volume. All these things, again, you typically don't see it 1 or 2Z, you see it at volume, right? And that's kind of the problem. It's not just a 1 or 2, it's how do they basically scale their attacks? What about yourself from a Charles Schwab perspective?
Yeah, thanks. So within the financial services industry, we have some of the same fraud schemes that Amazon sees. But right now, what we're seeing trending are these 6 schemes here. So new account fraud, which I'll come back to in a minute because we've got a case use to go over with you. And then online account takeover. So for us, it's very similar where the login credentials are compromised elsewhere, typically through one of those big breaches that we seem to hear about weekly in the news these days. And then the criminals get into the accounts. For us, what they're trying to do is just steal money. They want to get into our clients' accounts, and they want to move money out as quickly as possible. On the payment side, so many financial institutions are issuers of cards. We issue both debit cards and credit cards. And so what we see is either the card itself or the numbers are compromised, and then the criminals go out and use those cards elsewhere. Scams, email account takeover, and social engineering, all 3 of those involve an element of client manipulation. And so for today's purposes, we won't discuss those. The other 3 are purely online. So new account fraud. What we've seen traditionally in financial services is a lot of times the criminals are using a synthetic ID. So for those of you who aren't familiar with synthetic IDs, it's where they take bits and pieces of information, personal information from different individuals, and they compile it to make it look like one person. They'll apply for accounts. Obviously, if there's no criminal history, they're not going to get an account. They won't be granted one by the financial institutions. But every time they apply, that builds a credit history. And so if they apply to enough counts over time, it will then appear that this person is legitimate and that that history exists. And eventually, a bank is going to open an account in their name. What we then saw was criminals will sometimes use the new accounts to move small amounts of illegitimately obtained funds through the different institutions, and then typically out of the country. And once it's out of the country, the money's gone. But we had a recent incident that involved new accounts at 3 different financial institutions, but they were all interrelated. So what happened was the criminals took either stolen identity or what we consider true parties. So they got a number of individuals who either wittingly or unwittingly were assisting the criminal ring and opened accounts in their own names. Once the accounts were opened at the first institution, the criminals deposited funds. They waited for those funds to settle. They then went to the accounts at the second institution, and they pulled the funds from the first institution into the second institution, which they could do because they were like-named accounts. From the second institution, they placed a few trades just to make it look like these were legitimate accounts and legitimate activity. They waited for the funds to settle, and then they moved that money, they pushed it out from the second institution and into the third. And once it hit the third, they cleared out the accounts and they were gone. They did some through wires, they also obtained some debit cards, and they drained the accounts through ATM. What happened here, and it's worth noting that under the banking regulations, the institution that initiates those transactions is the one that's liable if there's a fraudulent act. And so the first bank, or the third bank, the money was gone. The criminals then went back to the first bank and said, hey, you know that pull that went over to the middle institution? Well, that was fraudulent, and we want you to give us our money back. So the first bank did, and they said to the second institution, you owe us. So the second institution had to send the money back. That middle institution was left sitting there holding the bag. And in this case, it was almost $350,000. They had no recourse. The criminals doubled their money in a matter of days because they took their first amount, they moved it all the way through, they put it in their right pocket, went back to the first institution and said, oh, that money was fraudulently moved, and then got that amount put in their left pocket. So what the firms found when they did their retrospective review, now they caught this fraud and really fairly early on, but not at the door. And so not until after the criminals had already gotten away with some of the money. But what they found when they looked back across these account attributes is there were a number of data points that were identical across all of these accounts. So the accounts were all open, the home address was all in Flushing, New York. The IP address, so everywhere that these accounts were accessed from, was all in the same town of Fresh Meadows, New York, so not very far away. The employment status of each individual was identified as homemaker. And then each of those clients, there were some that were requested because there were some questions early on when they opened the accounts. And so some of the institutions said, okay, we need you to come in person, so just come down to one of our branches and bring an ID. All of those IDs were a New York identity card, and they said temp visitor. There were also some additional data points that the firm saw behind the scenes. In addition to the IP address being the same, the screen size was the same. It was all the same time zone. The UA was the same, and the language packs were the same. And so if you take all of that data and you have the ability to see that at the get-go when the accounts are open, you'll be able to prevent a lot more fraud. But that wasn't the case in this instance.
So if you've taken nothing away from the couple examples, these are both new account fraud examples. In the case of the financial institution, their second company or separate bank was dealing with accounts being created, and again, the difference between who you say you are and who you are on the internet are two different things, and being able to understand that. From an AWS perspective, as accounts are getting created, same type of problem. Who you say you are and who you are can be sometimes two different things, and the ability to basically understand that is paramount. The other thing I think that we can agree is that these fraudsters, while they also work at volume, they don't stand still. Every time you find an angle or what they're using and you block that angle, they'll find a new angle. So for us, a lot of the earlier times, it was all around registrations at volume, and you would see these patterns, whether the pattern was IPs resolving from Japan and phone numbers that resolved to Spain, and you could see hundreds of these things getting created, and we would block these. And then guess what? They would find a new IP, or they would find a new payment instrument, or a new bank, and then they would just go down the same path. So the point I was trying to make from here is that it's not just about how you solve that new account problem, it's also basically how you've set up your strategy and your framework in order to be able to be nimble, adaptive, and flexible. We at Amazon have spent over a decade building up a fraud prevention system from the ground up to be just that. It's a framework. The framework consists of 4 different pillars: prevention, detection, remediation, as well as containment. Prevention is what we do at the door, right? If you could stop a bad actor at the door, that's the best case scenario. It's hard to do and not impact customers, good customers, but that's our number one strategy, is to figure out how we can effectively stop them at the door. But you're not going to stop everybody. Things slip through. People find new angles. And so you have to have a detection strategy, looking at behavior, looking at things that are anomalous, looking at things that you've defined to be abusive, right? And then taking those things and those items and those alerts and sending them to humans, sending them to an investigation team that looks at this and makes decisions. Not everything you detect is going to be fraudulent, right? And so having that layer of rigor in order to evaluate whether or not this is legitimate or not, be able to walk through an SOP, be able to follow a standard workflow to clean an account up or to validate whether it's a person is important, because again, you don't want to adversely impact legitimate customers. The fourth element for us is containment. Containment is very much, or very similar to what you think of with a credit card limit, right? If you're really well trusted, you get a high limit. If you're not so trusted, you might get a lower limit. And for us, we have a similar basically strategy overall, and that helps us limit the blast radius associated with a bad actor that gets through the front door and that starts to do something malicious. All 4 of these things working together, all 4 of these collect data. Things that we do in detection and we learn about in detection feeds data into the remediation, which feeds data back into the containment as well as prevention. Why? Because we want to basically get better at detecting stuff at the door, right? So sharing data, sharing mechanisms, sharing best practice around there is what makes this work for us. It's what basically has helped us drive fraud down to industry low levels. Now with that, it's not just about mechanisms, it's also about customer friction. I know you know a little bit about this since Charles Schwab, and you're trying to manage that, so.
Yeah. So for us, our vision statement is through clients' eyes. And so we're always looking for the best client experience and the least friction that we can provide. But we have to balance that with the risk of fraud. And so at the account open stage, we open accounts very, very quickly. It's the best way to give the client that very first great experience. But we also need to prevent the fraud. But the more friction we create, the more likelihood that a client's going to, or a potential client's going to try and open an account. If it's too difficult, they're just going to walk away, and they're going to go open an account elsewhere. Same thing with account takeover. We need to make sure that the criminals aren't getting into accounts and stealing our clients' money. But at the same time, we have to make sure that we're not preventing too many clients from taking action in their accounts, right? We're an online trading platform, and our clients want to trade immediately as soon as they have that trade come up. And so the more that we block, the more friction we create, the less of a client experience they're going to have. So friction is a huge issue and top of mind for us as we try to balance the fraud prevention aspect.
That is huge. And a personal anecdote for myself, a few weeks ago, like everyone else, you're looking at these financial institutions that have these great savings rates. And so I decided to open up an account from my house, from my machine, open the account, move money into this account, right? Everything's great, getting this great interest rate. 2 weeks or 3 weeks later, I decide, let's put a little more money in this account. This is great. I'm watching this go up. This is great. Same PC, same location, in my house, logging in. I get hit by their fraud prevention mechanisms. Okay, that's fine. I understand. You want to make sure who I am? Okay. 40 minutes later, 4 people I have talked to, I went from how do I get more money in to how do I get my money out?
This was not Schwab, by the way, just for the record.
So, from our perspective, balancing in Amazon, we take customer friction extremely, extremely important. And we are balancing everything we do with how it impacts legitimate customers. And you should too as well. So let's transition from kind of the MOs and kind of what we've observed into kind of the mechanisms behind and how we deal with this. Machine learning is paramount through all our systems. We've made large investments in machine learning over the course of the last 2 decades in order to help us improve lots of things at Amazon, including fraud prevention. Now, obviously when you start, you got to walk before you run. And by walking, we use business rules. We would do things such as describing the business rule I mentioned earlier. How do I basically block registrations, or not block registrations, or investigate things that come from similar patterns that we've seen in the past? IPs from certain locations, phone numbers from certain locations that we've seen created accounts at scale. And it's great. Business rules are easily explained. They're easy to implement. They're easy to validate. You can put them in place. If someone audits them, they understand what's going on. What's the problem? They're easy to work around. Right? Just like you can explain it, so do bad actors. They can just sit there and test your system, and they test your system, and they figure something out, and then they work around it. I like to call it above the line and below the line type of thing, right? If I set my threshold at looking at, let's just say, a cumulative transactions of $10,000 or greater, right? They'll work at 9,900, and if you set it, they'll work a little bit lower. So they don't generalize real well, right? Not that business rules are bad. They're great, they're effective, but they really needed to be complemented with machine learning. And one of the reasons and one that we use it is because it generalizes better. It helps us find those folks that are trying to work around those lines or find ways to circumvent those hard thresholds. And so, again, it's really good for us not just find the patterns, but also assess the risk. So let's dive a little bit more into machine learning because we use it throughout our 4 pillars, right, to help us basically get better. From a method perspective, for those of you that sat through all the sessions and those of you that are experts, you can probably tune out. You know all this. For my perspective, I'd like to kind of give you some background to the different methods. Reinforcement learning is an area where if you don't have data, you don't have, so to speak, history, and you're trying to train something new, you use that. Right? The deep racer is a great example. I'm trying to teach the car to go around the track. I don't have historical data. So I'm going through in a series of experiments and reinforcements, tell it whether it successfully did it or not, and thus I can then train a model. Not really basically a lot we're using in the fraud space, although we're doing some investigation with it for these cold start problems, but let's put that aside for right now. For majority of the models we use are either supervised or unsupervised, right? From an unsupervised perspective, it's more like clustering activity based on patterns you've seen in the past. And tell me when things are basically outside the norm. Great for things like account takeover, right? Amongst other stuff. Supervised is if you have history, I know what happened. I have labeled my data. So I have inputs about whether it's new accounts, whether it's payments, whether it's whatever. I know whether information about that account or that particular transaction, and I have labeled it whether it's fraud or not fraud. And from that sequence, I can then basically build models on top of that to then apply to future transactions. We're going to hone in on that just a second because a lot of what we're doing initially is based on the supervised level, as well as later on you'll hear some stuff about what we're doing on the unsupervised level too as well. So, again, for those that know ML, you can kind of tune out for a couple minutes, but for those of you that don't, let me just give you a little basic primer. From a supervised perspective, if you want to look at this plot and follow along, the blue squares are legitimate behavior, the orange circles are fraudulent. In this case, what I'm trying to do is I have a sequence of data, That data can be features that are categorical, numerical, or whatnot. It can be things describing where the IP originated, the email address as you saw earlier. It can be other things like shipping address, financial institutions, bank, all kinds of different pieces, as well as then a label. The label is fraud or not fraud, which is indicated by the colors and the size of the shapes. What we're trying to do now is to apply a sequence of algorithms or supervised learning algorithms to this particular plot in order to help us identify the optimal way in which I can draw a function around those bad actors such that then I can apply it to future data points. And again, I'm oversimplifying it. There's just 2 features in this particular example. You'll have hundreds, if not thousands, of features in your model. So how does this work? Well, basically, you take a data set, you split that data set between a training and a testing set, being sure to have an equal representation so that it's balanced. For various training purposes, depending upon how the data is set up, you may need to oversample, undersample. We'll then run and apply a various sequence of models. For our purposes inside of AWS fraud prevention, we do everything from logistic regressions to neural nets to trees to forests, you name it. Again, the science behind this is figuring out what model is best for your particular problem. It's not a one-size-fits-all, as well as you need to figure out what the parameters are and how to optimize those parameters so that you get, so to speak, the optimal model. And then applying that model to your training set to validate that it actually performs well. Great. OK, now we understand the ML piece. I've given you a little brief intro into kind of what we do, how it works. So what's different for us? Well, it's not all that different per se. It's a little bit about what we do in order to get that extra juice from the squeeze per se. So first, just like everyone else in the ML space, you're enriching your data. When you give something like an IP address, that's a great feature. But you know what? I can derive all kinds of attributes from that IP address. I can know what network it came from. I can figure out what the location of it came from. This is all fabulous information and data that can help basically improve the predictive nature of your model. Likewise for payment instruments, right? I can figure out what the issuing bank. You get the idea, right? We do this for a sequence of attributes that are given to us, enriching the data. We also engineer new features, right? We want to do things like help me find the distance between where the IP says you are to where your billing address is, right? These are all kind of indicative type things that you can help improve the predictive power of your model. Right? Last, we look at patterns. So, as you kind of would expect, we use data that we have against previous bad actors. And we take that data and we look for certain patterns. Through a sequence of deep neural networks, we develop patterns on emails, we develop patterns on IPs, we develop patterns on all kinds of different attributes. And guess what? Those patterns are inputs to our models, helping us basically learn from the past. So if something was marked fraud or we see a repeated bad actor using an MO, this actually intelligence finds its way into our modeling piece. Right? And so the sequence of activities, just to kind of name a few, are what we do in order to help us get that little extra lift. Now, for those of you that in this space, you know that building a model doesn't stop just with kind of the process of putting an algorithm, enriching it, engineering features, and building, so to speak, score code. It also requires you to, so to speak, close the loop, meaning I need to learn from the future. As we take actions on specific fraud MOs, as I'm looking at new accounts and we confirm them fraud or legit, I need to understand and take that labels and feed it back into my process, thus ensuring my model continues to learn from new behavior and continues to basically perform well, right? As I mentioned earlier, rules typically don't tend to have a good long shelf life. Models, at least on our side, typically stay in production between 3 and 18 months, depending upon performance. We do this for every model. We create basically our feedback that is used when we start to see performance degrade, we retrain. Okay? Now, from a rule perspective, we also still use rules not only for prevention pieces, we use them to interpret the model, right? So, for example, if a certain score bandwidth tranche, we might basically choose to investigate. What we want to do is to ensure, again, thinking about our 4 pillars, that I'm optimally using my human capital or the investigators as efficiently as possible. So I want to look at and say, Are these decisions the right decisions? Are the false positives appropriate and whatnot? And so we're continually basically looking at not only the models, the algorithms, how we tune the algorithms, how we're engineering features, how we're enriching data, but also how we're basically making this a closed loop system. So decades have gone into helping us build this. Nick, you want to talk a little bit about the service? Or?
Sure. To kick things off, as Kara and Ryan have been talking about, like, fraud detection is difficult, as evidenced by how much money is lost each year, the constantly changing tactics by fraudsters. In talking with various fraud teams, we commonly hear that when your detection mechanisms aren't precise, it results in more costly manual reviews. And then also, we hear about how a lot of fraud teams don't have embedded engineering resources or data scientists, so they're often relying on other parts of the organization. And we also, one last thing we hear is that the detection logic often ends up embedded in code, and so fraud teams don't necessarily have the flexibility to adjust their detection on the fly to respond to the changing tactics. Then when you add on machine learning to your fraud detection systems, there's an additional set of challenges. First, ML expertise is hard to come by and expensive. When you try to use generic models that aren't customized to your data set, you often leave performance on the table. Then there's a lot of time spent transforming your data, enriching your data, and engineering the features. We often talk to fraud teams that integrate with multiple data vendor APIs just to enrich that data to get to the performance that they want. That takes time. And then finally, you have some unique challenges with your feature engineering for the fraud space where you have imbalance. Oftentimes, you have fraud use cases where you're looking for a needle in the haystack. You're looking for those less than 1% of fraudulent events out of everything that you're processing. So to help customers solve these challenges, we built Amazon Fraud Detector. Amazon Fraud Detector will help you catch more online fraud faster. What is Amazon Fraud Detector? It's a fully managed fraud detection service that makes it easy for businesses to use machine learning to catch online fraud at scale in real time. I'll take you through a few of the benefits of Amazon Fraud Detector. First, the service enables you to build high-quality models using templates. So a template roughly aligns to a use case or set of fraud use cases. What you do with Amazon Fraud Detector is you upload your data into Amazon S3, select the template that you want to train your model with, and then the fraud detector will train that model using a fully automated ML pipeline, output your custom model with some performance metrics. Ryan will go into more detail about each step of that auto ML process in a little bit. Next, Amazon Fraud Detector enables you to catch more fraudsters at the front door before they can do harm. We do this by using advanced ML techniques that don't rely on tons of historical data about a particular account, so we can effectively catch those fraudsters with the limited information you have, say, at account creation. Again, we are building Amazon Fraud Detector using the same machine learning experts that build the models that protect AWS and Amazon.com, and we've built that expertise into the template. So you can think of a template as a recipe, so to speak. So, for example, we use a lot of similar techniques in Amazon Fraud Detector that we use in the models that protect AWS account registration. So today with AWS account signups, we adjust step 2, 3, and 4 of the signup process based on the model that we're running to predict risk on step 1, similar to the demo that I gave earlier. And then finally, Amazon Fraud Detector gives fraud teams more control. One, by automating the complex ML process to get a high-quality model, we're going to save the fraud team time. Second, by offering a GUI console that lets you control when you train models, manage those models, update those models, attach rules to those models, you have more control about swapping out and updating your detection systems on the fly. In terms of use cases that Amazon Fraud Detector is designed for, you can really think of the service as designed to detect common types of online fraud. And the list will expand over time, but some of the core examples to start with are the ones we've been talking about earlier. New account fraud, online payment fraud. And then there's a couple variations. I like to call it guest checkout. It's a variation of online payment fraud, but in this case, you don't have that account history to rely on to make your fraud decisions. So you're operating, making decisions with less data. And then use cases similar to what Ryan explained, Amazon or AWS handles, where you have a business model that you offer goods or services before you collect payment, so the post-paid model. Okay, how does it work? First, step one, you upload your historical training data to Amazon S3. Next, in the console for Amazon Fraud Detector, you select the model template that you want to use for your use case, and then Amazon Fraud Detector will take the data that you uploaded, put it through the AutoML process, create your custom model. Once that's complete, you can draft some decision rules to interpret the outcome from that model in what we call a detector. And once you have your detector defined, you can publish it and use the API to send events in real time to Amazon Fraud Detector. We'll process those events against your detection logic and return the outcome, as well as any scores from models you use as part of your detector. Based on that, you can adjust the customer experience and take action. As an example, say you have a guest checkout experience, a customer places an order, your web application accepts that order, you pass on the details about that order to your custom fraud detection endpoint, and we process that, return the outcome and the score. Based on that score, you could accept the order, ask for some additional verification, or otherwise adjust the customer experience.
I'll get some key features here. So there's a number of things that I'm excited about with this new service. More than I can probably go into detail here, but there are a few that I want to point out to you. We talked about these templates. Let me just give you a little more detail on these templates. You can think of them as use cases. It's recipes that are going to make it easy for you to quickly, effectively train a model that's directed at solving a specific type of problem, right? We're doing all the lifting. We're using all the stuff that we have learned through the decades, as well as some information that we've figured out how to get lift in some of these problems are in these templates. As Nick alluded, there's one in the service right now that I'm going to talk about in a second. There will be multiple more coming in the public preview around account takeover and payments, as well as we're looking to expand that list. Again, it's a recipe that helps you accelerate your time to value, helping you, putting the opportunity for you to train your model and your fraud prevention mechanisms at your pace, so to speak, and you're not going to have to worry about another vendor to build this thing or wait for someone to build a commodity type model. It's built on your data, right? That's the other thing that I want to point out. You're not basically looking at a data set that may not generalize to your problem. This particular service, when you provide historical data, is tuned for your specific problem, as well as you're getting lift from Amazon in our experience. It comes in not only basically how you build the model, but we're also taking the patterns from repeated bad actors through a series of deep neural networks, making them available in our AutoML process that would then basically give your endpoint lift, right? So now not only basically are we training on what you know, but you're also going to get a little bit of juice from what we know, right? Helping improve your capture rate on fraud. Now, for those of you that are into SageMaker and are passionate about the different types of techniques, we integrate with SageMaker, right? You import a SageMaker model. You can write your rules against that SageMaker model. So it gives you the flexibility basically to use the service or to integrate the service with SageMaker where you have a lot more control over what specific mechanisms you're using. Last but not least, the key things is everything is auditable. Everything is, you can search and find out. In the console, and you're going to see in a little bit, when you make a call to an endpoint that's a model you built, you'll be able to go through and audit what the call was, what the parameters were sent, what the outcome was, what rules fired, right? Enabling you to completely go back through this and figure it out. So again, these are just a few of the things that I'm excited about. There's a longer list in there, and one of the things I want to talk about a little bit now is the existing template that's in the public preview. It's called Online Fraud Insights. Now, you probably heard us go into a lot of detail about how we have to deal with new accounts. accounts that we don't know a lot about, customers that don't have a lot of history with us. And so the first template out there is called Online Fraud Insights, and it's helping you assess risk when situations where you don't have a lot of history, where you don't have a lot of data. We use it for new account registration or a version of it. But applications are first transaction, guest checkout, new account registration. One of the valuable things about it is it doesn't require a lot of different features to get started. We do map out about 53 different features. 4 of them are required, the others are optional, right? The more data and features you can put in, obviously the better the model's going to perform, but it allows you to get started without having a lot of different features to get started. The other thing I want to point out is if the data that you have that you know has predictive power isn't on our list, we have support custom attributes. So you can specify a custom numerical, a custom categorical variable, and it'll be included in the model process, and it'll get equal rate, and if it turns out that it's predictive and has predictive power, it'll be used as well in this process as well. So what do we do behind the scenes of this thing? So again, Nick said there's an S3 bucket. It has your data set in it, in your account. The first thing, of course, is we're going to validate it. So if you're using the service and your data is not as in the format you need to be, or let's just say you have some missing values, you'll get some error messages back that will tell you and give you some instruction. Hey, your labels, you have a certain percentage of missing labels. You need to go back and clean that in your training data set and whatnot, just to give you a couple examples. We're then going to go through and enrich the variables, looking at both some of our lessons and some of the things that we go to figure out things such as where that IP came from and some other pieces in order to use these variables and transformations as inputs into our model. Again, just like I told you before, we're going to engineer some features, do some magic in order to get some predictive power. We're then going to run through a sequence of models, as well as basically using parameter optimization to tune the models, looking at which one is the best performing, and then provide those metrics back to you so that you can see of the model that was built that was best performing. Here's basically what some of the metrics are that will help guide you on your journey to identifying what the appropriate cutoff is. And then, of course, we support the deployment. One of the nice things about what we have right now is you can have an endpoint that will have both a production as well as drafts that you're going to see in a second. So you can have something that's running and other things that you're testing at the same time, which makes it nice to kind of do that, so to speak, analysis and seeing if some different ways to approach this are going to be more beneficial than others. So that's what's in a nutshell. Why don't we just kind of jump in and show you the service? Nick, why don't you, if you don't mind, opening up the demo here and.
Okay, here we go. So we're in the Amazon Fraud Detector console. So we're going to go through 2 main flows. The first flow we're going to go through is to create a model, and then we're going to open up a detector, look at the logic that's been configured, and modify that so you get a sense for how you'd use the console. And here we go. So we'll click on Build Model. Let's give this a name here. We'll call this Registration Model. And this third field down is where you'd select your model template. We're going to use Online Fraud Insights for this demo. You get a little information about the template here with the required fields. Then the second container down here is where you would give the service permission to access your training data set. We're going to select the role that we pre-created, and then we're going to put in an S3 location. I've got the window open. I'm going to copy the path from S3 and paste it in here. Once I hit next, the service pulls in the headers from your training data set and maps them. Up top here, you'll see your status. Once you have each of these 4 inputs marked as ready, you can move on to the next step to train the model. We have 3 of 4 mapped automatically because we've used this data set before, so some of the input variables are already created in the system, but we have to still do the fraud label piece. So we're going to select input here, and we're going to select fraud label. And so now we're ready to go. One thing I want to point out before we go further, just to give you a sense of the training data set that we're using here. It's the bare minimum training set you'd need for online fraud insights model. It's got an IP address column, an email address column, event timestamp, and a fraud label column. You'll notice each row is an independent record, and then in the fraud label column, a 0 represents a legitimate event, and a 1 represents a fraudulent event. And so we'll come back here to the console. We've mapped those inputs. Down below here, we need to understand a little bit more about the values in your label column. So what represents fraud, what represents legit. In this case, a 1 represents the fraud, and a 0 represents the legit. Now we'll hit next. At this point, we're simply reviewing what we've configured, making sure everything looks right. And we can hit create and train model. You can train it now or you can train it later. We're going to train it now. And we end up on this new screen. We see that the model has been created, and we have version 1.0 of this model, and it's in training status. So this takes a few minutes to train. So we're going to go back and look at a trained version. We'll come over here to models. We'll go down to this fraud model here. You'll see this model has 2 different versions. They're both active. We'll go into 1.0 here. And so when a model trains, we output the performance metrics. We'll give you a high-level metric of area under the curve to just generally get a sense for how well this model performs. In this case, it's 0.95. Based on our experience in AWS, a model that's 0.95 is generally considered a very high-performing model. And then below, some of the summary information to help you interpret the model is a table sorted by false positive rate. So typically, fraud teams and our team in AWS, we're looking at a particular operating range for our models. Most of our use cases require us to be in the 0% to 5% false positive rate. Oftentimes, it's at 0.5 to 1%. What this table allows you to do is, based on your operating range, understand how much fraud you can capture, and then what threshold you would use for a business rule to interpret the model's output. So in this case, if we were okay with accepting a false positive rate of 4%, so that 4% of legitimate events were incorrectly labeled as fraud, we could capture 76% of the fraud. If we used a threshold rule that said any scores above 229 mark as high risk. Likewise, if you're queuing events for manual investigation, oftentimes teams want to look at their yields on their review queues. So in that case, if you had a rule that queued for investigation anything over 229, 67% of the events that you sent to investigators would turn out to be fraudulent. In this case, if I liked the performance of this model and I wanted to use it for real-time fraud detection, I would come up here and I would hit this. Since this is already deployed, I would undeploy it, but this would say deploy model version. I click deploy model version, and in about 5 minutes, that model is available to use for real-time fraud detection. Now, once you have your models, then you want to create your detector. And a detector, as I said earlier, think of it as a container to hold the model or models plus the rule set you want to use when you're sending events for evaluation. In this case, I have one created here called Sign-Up Detector that's very similar to what was used behind the scenes for our first demo. You'll see here, I have 2 versions of this detector. One's active and one's in draft. Let's go into the active one and look at the detection logic that's being used. So you'll see here that it's very simple from a rule set standpoint. We have 2 rules, a low-risk pass and a high-risk verify, and they're simply interpreting the output of the model score. So less than or equal to 400 and greater than 400. If one of these rules matches, the API will return the appropriate outcome. And you'll see down below that there's one model being used in this detector. With the Amazon Fraud Detector, you can have multiple models in one detector, and you can mix fraud detector models and Amazon SageMaker endpoints. So let's say we want to adjust the logic of this detector. Let's go into Actions and duplicate this. We're going to keep the description the same. We'll come into here. This would be the step where I adjust what models I want to use. So if I created a new version of my model and I want to swap out a new account fraud 1.0 for 2.0, I would come in here, I would hit add model, and I'd remove this model and make that swap. For now, we'll keep the same model. On step 3, this is where you'd add new rules. To give you an idea of how the rules work, we'll go in here and edit the threshold score for these rules. So we'll go edit, come down here to the expression box, and let's move the threshold up to 500. We'll save that change. And then we'll come down to the high-risk verify rule, and we'll also adjust the threshold to 500. And let's say here that instead of SMS as an outcome, we want to do a phone verification. So let's create a new outcome. We'll call it phone. Save that. And now you'll see that if this rule matches, not only will we return any of the scores from the models, but we'll return both of these outcomes, high-risk verify and phone, to potentially trigger 2 different experiences in your product. Save changes. We'll move forward with these 2 rules. The last step is to adjust the priority for the rules. Oftentimes when you have a more complex rule set, you'll want certain rules to be evaluated first. Say you have a whitelist and you just want to automatically pass a list of known accounts. You would put that at the top and have that run first. These execute in priority order. Because we have 2 right now, we'll just keep it the same. And then the last step here is review and create, similar to when we were creating a model. So now we have this new version. It's in draft status. Let's say we created this. Now we want to test our detection logic. Down below, we have a run test UI. So you can enter in some test evaluations. And see if the detection logic is working as you'd expect. In this case, we put in some dummy information. We received an outcome of low-risk pass and a model score of 361. If we liked what we saw here and we wanted to put this into production and use it with the API, we would come up here to action and hit publish. And at that point, the API will call, when you call the API, it'll run the evaluation against your active version of your detector. You could also use the API to run against draft evaluations or detectors if you want, but by default, it will always execute against your active detector. Now, let's say you've been sending events for evaluation to Amazon Fraud Detector for a while, and you want to go back and see how a particular outcome was arrived at. You'd come over here to search past evaluations, and you could enter some filters to filter down all your past events to the ones that you're interested in. Once you do that, you'd click on a particular event, and you get this summary of the prediction. This area right here is where you would see what was received with your API call, so the raw data that we used to input into the evaluation. Then you get a summary of any models and rules that were used as part of this evaluation. And then if you wanted to dive deeper into a particular rule, for instance, say we're using very simple conditions here, but if oftentimes fraud teams will have real long conditions that are a bit complex. If you wanted to go in and see exactly what happened when it executed, you can come down here and see that here's the expression for the rule, and then here's the expression with the raw values that we received, and this is how it executed. So you can kind of tie it all together to understand how a decision was arrived at. And with that, I'll pass it back to Ryan and Kara to wrap things up.
Yeah.
Good.
Thanks, Nick. So I think that Amazon Fraud Detector is a great new tool in the fraud fighting arsenal. If you think back to the example I gave earlier, the financial institutions were able to stop that fraud fairly early on, but they didn't have the capability to make that detection really at the account opening stage, right, when the criminals came to the door. And so taking Amazon Fraud Detector and coupling that historical data that financial institutions and other companies have along with the data and the experience that Amazon has, I think is going to really enhance this fight and enable fraud detection and prevention much earlier and much quicker.
Yeah, thank you, Kara. Let's go back to the slides if you would. Now, for those of you that are interested in getting started, I want to give you a little bit of kind of final information here, and then we can open it up. For a preview perspective, we are in public preview. If you go out into Amazon and you look for Fraud Detector at the URL behind us, you'll be able to submit a request and to be acted into the public preview. We plan to have that preview around here for a little while here as we add in a few more templates. As we mentioned, account takeover and some of the payment stuff is top of mind to us. But to use the online insights, which is available today, it's pretty simple to get forward or to get started. Again, you need a minimal of 10,000 attributes in a CSV file or 10,000 rows in a CSV file with the required attributes, labeled appropriately. And again, it'll be an S3 bucket in your account in a CSV format. And so from there, you can get started and start building your own models and writing your own rules and trying it out. So with that, I hope you found this informative and educational. Again, here's some of the contact information for the three of us. Feel free to use and text us during reasonable hours, of course, because I will silent my phone at night. But yeah, why don't we have a few minutes here. I want to open up for a question or two. And if you would, come to the microphone, please, because it's pretty hard for others to hear. So if someone wants to go to the microphone. Pricing is on the website.
I'm sure you had a chance to run this against how you're doing it now and how you were doing it. What's the difference in performance or the improvement you've seen from it?
I'm sorry, before.
Well, Schwab has been doing, I guess
Oh.
they're using this model. So what's the effect or what's the difference in performance you had from the previous method you were using when you added this on top of it?
So from a Schwab perspective, we've been actually working with a number of different customers, and we've seen lift across a number of customers, anywhere from nominal 10, 15% to upwards of 80% capture rate difference from what they saw in the past. And this was against their existing systems or existing things they've seen. Yes, sir.
I have two questions. So for first thing, do you guarantee any sort of like prediction latency SLAs in terms of how long it could take? And the other question is, are you providing your customer any insight into how the score is calculated in the first place?
So the first answer to your question is, right now in the public preview, it's 200 milliseconds, and when we go to GA, we'll be sub 100, and we'll put SLAs on, so to speak, that. In certain situations, of course, our SLAs will be different because certain use cases require certain types of SLAs where other ones you have more time. And your second question was, reason codes. We don't have reason codes in the tool today. We are evaluating it amongst other things based on voice of the customer. If you need to have complete transparency, then my recommendation right now would be to use the score in addition to SageMaker, and then you can get complete transparency into what's going on. But yeah, the long and short of an answer is it's on our list of things that we're going to have to do.
Oh, thanks. Yeah, fun fact, my company does, we make a real-time inference API for doing account takeover fraud detection. So looking forward to learn from you.
All right, thank you.
So I kind of follow on to that. What about preventing discrimination and fair lending things?
Well, so in our attributes right now, there's nothing that is anything related to gender, race, anything along those lines. We don't use this in any of our models, nor would we recommend you use it in these models. So we don't include that. For purposes of these models, they're not credit lending models, they're fraud prevention models. So we do not recommend you use them to make credit decisions or anything around that would be fair lending.
What about CCPA and somebody asking to have their data removed?
So from a fraud prevention or a GDPR perspective, there is a delete. So you as a customer have an opportunity to delete any data that's basically you're passing to this.
Okay, and then the fraud model doesn't have that anymore, and then we don't know.
Yeah, so from your side of it, you control this. So if you pass data and you want to delete that data, then you call the delete API.
Okay, thanks.
Okay. One last question, and then we can take some after. Go ahead.
From a technical perspective, what do you actually return from the API? So like if I wanted to ensemble this with the stuff that we've already built, like does it come back with the score? And like...
So it comes back with a score and then any of the outcomes you've defined in your detector.
Okay, and a standardized format?
Yes. Yep.
Beautiful.
Okay.
Thank you.
All right, listen, I appreciate this. Thanks for your time and attention, and we'll hang around for a few minutes for those of you who don't catch us up. So thanks.